So we're gonna have a look at the 2019 Chemistry Unit 1 paper 1 now, going a bit faster. So the volatility, we're saying that the volatility here, right, we chose C as it. So the repeats are coming in. This would be 3 for the molecular formula of pentane, these isomers. This would be C6H12 for the molecular formula of that compound, right? Which of the following statements is true for the nitration of benzene? It is a yellow liquid. It's formed. Based on the IPAC rules, this is 1-phenylpropan, 2-amine. I hope you guys are fine so far. Everybody fine with this page? These are all repeats.
Yes.
Alright. Hopefully these are all repeats as well, and they all are. Wait, technically this isn't, but you guys should know this. So this would be free radical substitution. Here would be C for this one, right, hydrolyzed by water. And then we have here, remember that we're talking about the interaction with the OH group. They switched where we're working on this, right? So the answer should give us, hold on, we're using ethanol chloride and a phenol. This should give us an ester linkage, which should be C double bond O should give us COO. Right, so I think that the answer should be what? D. Everybody agrees with this?
Yes, sir.
Sure. Alright. Moving on. Which of the following pairs of compounds are optical isomers? It has to be chiral. These have this, wait, hold on. I just already attacked it. Okay, this is what I'm talking about. These have the same groups. Methyl, this is wrong. Just have different groups. So this is different from this, and this. So these are the optical isomers or enantiomers. In case they want to drop in the different terms, make sure you know all the terms in case they give different questions. Hopefully they don't give anything new. Right? So the organic liquid here, we know that it's a carboxylic acid based off of what we did before. I'm just gonna be moving through the ones repeated, so if you have an issue, just stop me. Methylbenzene can react to produce parachloromethylbenzene or 4-chloromethylbenzene. Which of the following reagents and conditions are most suitable for the reaction? Tell me.
A.
So we need a Friedel-Crafts reagent and obviously chlorine. So Friedel-Crafts reagent is any metal complex that can bind to give us 3 of the halogen, right, on it. So it could be iron in its +3 state, it could be aluminum, it could be silver. Well, we don't normally use silver, we use Al, or we use Fe. Right? Down here we're looking at another repeat. Right, so the following, another repeat. Right, let's look at this tyrosine. The pH of tyrosine will most likely be
5.6 B.
5.6. So we have an acidic group up here, and we have a slightly acidic group here, and we have a basic group here. So it wouldn't be too acidic, and it wouldn't be too basic, and it would never be neutral. So the answer should be 5.6. Which of the following, what would be observed when aqueous bromine is added to this? So we know that the color should disappear and a white precipitate is made. That is a repeat as well. Alright. Here we're looking at this now, this chromatogram. We saw this already. Y is more strongly attached and Y has a small R value. Right, and we're looking here now, which of the following analytical techniques is considered more specific? We know it's mass spec. The compound absorbs light at a frequency of that, and the wavelength in cm cube of the light absorbed is here, right? So the wavelength, right? So lambda is equal to what? Wavelength is equal to what? The speed of light
upon the
over frequency.
Over frequency, right? And it is megahertz here, so we're going to have to times it by a million, right, to get the answer. So we're going to have to times it by a million and divide it by this. Divide the speed of light by it, right? So times that by a million for me, please. We can just use indices to be very honest, but you know, times it by a million, right? You could use your index form, or if you want to change it into a logarithm, I'm just joking. But you should be fine there. So get it to your index form if you want, and then divide it by the speed of light. What is the answer?
A.
A should be the answer. All right. So wonderful. Moving. Everybody fine though. Because if I
Yeah,
put
just
this on the
remember.
paper, you should be able to convert megahertz because mega means a million. So it's a million, right? So you just need to convert it back to hertz. All right. The treatment. Okay, we saw this as well. This answer is B. All right. So looking at this now, all of this for what? Because they're just reading all of that. The only thing that you need from this question is the yield. So the student carry out all of that. We don't really care about that. We're just balancing the equation and making sure that the state symbol of our lead chloride is obviously going to be solid. Right? The concentration of lead chloride in the original solution. How do we calculate that? So the student carries a gravimetric analysis in the soil sample from an area surrounding a garage, right? The soil sample is found to be contaminated with lead ions. 100 cm cube of solution, that is the volume, 100 cm cube, right? The solution is obtained from the sample mixed with 25 cm cube of 0.1 dm cube HCl, right? Yields that. So what is the concentration of lead ions? We know the concentration of HCl, right? And we know it to be a 1 to 2 ratio. So what do we do? We need to know the mass of lead chloride that exists, right? We have 1 mole of lead chloride. Give me the mass of lead chloride, and you should be able to give me the concentration, because concentration, it could be mass concentration or mole concentration. You could use the mass to convert it to mole to give me my molar concentration. So what is my answer, guys? I know that we have no issues with that.
God, be yeah, I got bees and boy.
Everybody else got B?
Check for that one.
Sir.
Alright, everybody else got B for real? Not hearing everybody else.
Sorry, what was it, sir?
I'm asking if everybody
Multiply.
else got. Oh, what we're doing, right? No, I didn't tell you to multiply anything or anything like that yet, you know, right? Right, I'm insinuating now. In order to get the molar concentration, we have our if we got D for 20, right? We already have our equation right here, so we know it's going to be a 1 to 2 ratio. So what you need to know is the mass of lead chloride. Well, yeah, we need to know the mass of lead chloride specifically, right? And relate that mass to get our moles, and then put it into the mole ratio, right? And then what we're supposed to do now is probably get the mole divided by the volume, which is the molar concentration. Volume in dm cube. So you're going to have to change the volume from cm cube if it is in cm cube.
Okay.
Everybody got the B?
Yes.
You see, if another mosquito bite me, I am going to end this meeting. All right. The complexity, well, the complex ion here has a molar. Oh, we looked at this earlier. What was the answer?
C.
See,
Alright, let me just write the equation for good measure. Right, oh sorry. Alpha is going to be equal to epsilon CL. You guys should be good. That means that C is A upon epsilon L. The answer is what?
E.
C as in cat?
Yes, sir.
Alright, so we have that. The inferred spectrum of an organic whatever. Alright, so we looked at this already. If it repeats, my bad for not really reading the questions properly. Alright, we got what? C for this answer as well.
Yes, sir.
Because we don't want to waste too much time, you know. I was about to say too many time. Wow. Alright, so the infrared spectroscopy, right? Our infrared spectroscopy is widely used to monitor atmospheric pollutants. Which of the following atmospheric pollutants is not usually monitored by? Okay, so we know this to be what? CO2. The mass spectrometer, right? Or
B.
okay, in the mass
and
spectrometer,
boy.
Question, sir. Why wasn't it the ozone?
Repeat.
Why wasn't it A, sir?
Why wasn't it ozone? Ozone
Because he
specifically.
said not used.
Oh wait, not normally. Isn't the answer B though? You're asking why not ozone?
Yeah.
Alright. Ozone generally, I think ozone can be a pollutant, right? But it's not generally referred to as an atmospheric pollutant like that. But ozone specifically should have higher reactivity, right, within the IR spectrum. That means that if it has a high activity in IR, that means it can be detected. Generally, it's usually monitored using IR spec. Right? With CO2, it doesn't really have that much, right, of an impact on IR spec. That's why it won't normally you don't normally have it being monitored using IR. It's just looking at the molecules and the capabilities for IR activity, to be very honest. So look at the molecule and look at the double bonds
Okay.
or free electrons or whatever, right? And look at the dipole as well. I think there's usually symmetrical stretching in CO2 as well that doesn't really help its case. Like I know that symmetrical stretching doesn't account for it or doesn't give us a IR spec properly. In the mass spectrometer, a molecular ion is formed from a compound by the loss of an electron. Which of the following may be eliminated in calibrating the systematic errors only? Hoping remember these. In the chromatogram, alright, so we looked at this already. So it said that, or was it all of the above? Let me see. Compound A is more soluble in the stationary phase, alright, is most I mean. Compound B is more polar than compound C. What is the soluble? This is what? What's a phase? I wanna know. Oh, tetrachloromethane was a mobile phase. So is more polar than compound C. So all of them is true.
I believe it's 1 and 3.
Or 1 and 3. Oh, I just saw it. So compound C is the most polar of the components. Alright, so 1 and 3, right? So 1 and 3. Right? So which of the following bonds would show the strongest absorption? IR, we're looking at oxygen and hydrogen. Right?
It has to
So
be 1 and 2, I believe.
wait, you said hold on.
Wait.
C is the most polar out of all of them.
Yeah.
Oh yeah, for really supposed to be 1 and 2, right?
Wait,
If you
yes.
if you look, go ahead.
Jay,
Hello.
are you here?
I think it's lagging. I think the entire system is lagging. So if I go up, right, let me look at it
Yeah.
properly. So compound A is all right. So 1 has to be in it.
I
Compound
was
B is
saying
more
1 and 2 had
polar.
to be the answer.
1 and 2 that have to be the answer. All right, that should be a little bit better.
Are you here?
All right, so we have that there. Now let's look at this. So which of the following features are advantages of steam distillation? You guys went with all of them to be the answer, right? Agreed?
Sir,
Go ahead.
for 1 and 2, does polarity have to do with adsorbance?
Adsorption. Polarity does have to do with it. Because we're saying that the mobile phase is non-polar, therefore the more polar the thing is, right, that would be the less the R value. Right? And B has a smaller R value than C. That means that B should be more polar than C.
Yeah.
All right. Okay. Let's have a look at. Let me check. Did I miss a page? No. All right. So let me allow the page to load it. All right. So, boy, the page move. Sorry about this. Which of the following is not a greenhouse gas? What's the answer? Not a greenhouse gas. Guys, you guys can hear me, right? Which is not a greenhouse gas.
B.
B,
B.
the ammonia is in.
Yeah,
Yes.
Basin boy.
Alright. So I need to make sure that is that I
Yes, sir.
heard.
Yes.
The presence of phosphate ions can be detected using. Oh, sorry, I skipped that one. Right, so we're looking at this now. The Bosch-Haber process. N2 and H2 can be obtained from X and Y respectively. Which of the following pairs best describes X and Y? What would be the answer?
C.
C, as in cat.
Sir, C as in cat.
Why?
Sir, C.
Why? Do we all agree with C?
Yeah.
Yes, sir.
Yeah.
Okay. The presence of
What if
phosphate.
you use distillation of liquid air to get the nitrogen?
Mhm.
And what do? You do something to hydrocarbon, not to the hydrocarbon to get the hydrogen.
Remember that the naphtha is a hydro. Yeah. So as you said, the naphtha is a hydrocarbon, meaning we'll have a lot of
Oh,
hydrogen. So when
steam.
we dehydrogenate it, right? Steam reformation.
Wait, can you hear me?
Oh, I can hear you now. I think it's
I was
lagged.
saying steam reformation of a hydrocarbon to
Yeah.
get the hydrogen.
The presence of phosphate ions can be detected by, we know it should be ammonium molybdate, right? We're looking at here now, which is the most appropriate, can't see the page though, inference based on the observation above. So HCl was added to water, sample drop by drop, and a white precipitate was formed. So we said that this would be or lead. Alright, so we saw this repeating as well. The product would be ALOH3. Alright, so see that most of them start repeating. Alright, I want this page to clear up. Give me 1 second, guys. Let me plug in this thing. So the anode is made up of titanium and inert, and with an inert coating of ruthenium oxide. Alright, so working off of that. Right, chlorofluorocarbons, we looked at this. We choose as the answer. Which of the following methods are used in the purification of water? Would be all of the above. Okay, can you guys? Oh, they. Why I'm trying my best, but the internet keeps on going with them. I don't want to leave them out of it. Alright, alright, my apologies guys, my laptop died in the middle of it, so I forced it to turn on again so we can complete this. So, alright, I have to move quickly. Alright, so 30, which of the following methods are used in the purification of water? We have that. Can you guys hear me and see the screen?
Yes, sir.
Alright, 39, the production of sulfuric acid by the contact process is an exothermic reaction. Which of the following conditions would favor the forward? If it's exothermic, we need an endothermic environment, right? So low temperature, right? If we have 3 number of moles of gases over here and we have 2, right? If we increase the pressure, we will favor the least amount of moles. Therefore, low pressure will not be the answer, and we need excess oxygen. Not true?
Yes, sir.
Alright. Le Chatelet's principles, right? Our principle. One principle governs all of that, right? We saw this as well. How did that? We saw this as well. Ammonium salts, right? They're just repeating. Which of the following resources are normally associated with the formation of photochemical smog? We saw all of these. This as well. Which of the following is not manufactured using ammonia? Ethanol. We saw that already. Which of the following compound is not a primary pollutant? We saw that already. We saw this already. All of that repeat back, right? So that was 2019's paper. You guys are fine?
Yeah.
I remember to save and send.
Hopefully I shall remember.